Imagine you are building a complex structure, and instead of giving step-by-step instructions, you simply provide a blueprint of the finished building. That is precisely the magic of declarative configuration, especially in powerful systems like Kubernetes. It is a fundamental concept that transforms how we manage and deploy applications. At its core, declarative configuration in Kubernetes means you define the desired state of your applications and infrastructure using configuration files, typically written in YAML. You tell Kubernetes what you want, like wanting 3 copies of your web server running, with a specific amount of memory and network access. Kubernetes then takes on the responsibility of making sure the current state matches your desired state, continuously monitoring and adjusting as needed. The why behind this approach is deeply rooted in efficiency, consistency, and resilience. Unlike imperative configuration, where you issue a series of commands to reach a state, declarative configuration focuses on the outcome. Kubernetes achieves this through its control plane components, especially the controller manager. This system constantly observes the current state of your cluster and compares it to the desired state you declared. If there is a discrepancy, the relevant controllers spring into action to reconcile the difference, always striving to bring the system back to your specified configuration. This ensures that even if something fails, Kubernetes automatically self-heals and maintains your intended setup. To put this into practice, you primarily interact with Kubernetes by creating or updating manifest files, which are the declarative blueprints. For instance, you might write a deployment manifest that specifies your container image, the number of replicas, and resource limits. You then submit this file to the Kubernetes API, and the system intelligently figures out the necessary steps to deploy, scale, and manage your application across the cluster. This abstraction allows you to focus on your application's requirements rather than the intricate details of cluster operations. A key benefit of this declarative model is its inherent idempotency. This means applying the same configuration multiple times will always yield the same result without unintended side effects. If a resource already exists as defined, Kubernetes simply does nothing. If it is missing, Kubernetes creates it. This predictability simplifies automation and continuous deployment pipelines significantly. It also naturally supports version control, allowing you to track changes to your infrastructure as easily as you track changes to your application code. Ultimately, embracing declarative configuration in Kubernetes empowers you to manage highly complex, distributed systems with remarkable simplicity and reliability. By clearly stating your intent, you enable Kubernetes to act as a tireless, intelligent operator, constantly working to achieve and maintain your desired environment. This shifts the focus from managing individual machines and processes to defining the overarching system architecture, fostering a more robust and scalable operational model for your applications.
If this helps you code smarter, like, subscribe, and stay tuned for more.